dx equals xy. Okay. So basically what I need to do here is I need to get the x's and the dx on one side, and I need to get the y and the dy on the other side. Okay, so in order to do that, what I'm going to go ahead and do is I'm going to go ahead and move the y. Now I'm going to move the y to the left. The reason why I'm going to do that is because the dy is already in the numerator. Okay, so that's a good one to have. So right now, what I'm going to end up having on the left side is I'm going to end up having x squared plus 4 over dx times dy over y equals x. Now hopefully you saw that I went ahead and moved that dx over to the left so that it is right underneath the x squared plus the 4 times dx. And so now my y's are good. What I'm going to do here is just go ahead and flip and multiply. So I'm going to go ahead and multiply that by dx over x squared plus 4. So on the left, when I do that, I'm left with dy over y. On the right, I'm left with x over x squared plus 4 times dx. Now, yes, in order to undo the dx and the dy, I'm going to integrate. What will the dy over y integrate to be? dy over y. Similar to du over u. ln, there you go. ln of y. So remember, whenever I have like a du over u, in this case it could be dy over y, it could be dx over x. And so if I look at the next one on the right side, what do you notice I have there? Yep. U is going to be x squared plus 4. So du is 2x. So I need a 1/2 out. So really this will be 1/2 natural log of x squared plus 4. And then I need my plus c. Okay? So then now I need to solve that. Okay? So to solve that, what do I need to do then? How do I get rid of the ln? Okay, first thing I'm going to do before I do the e to both sides, though, is I'm going to go ahead and move this 1/2 up. Okay, so really what ends up happening is you end up having a square root. So I have the natural log of y equals natural log of x squared plus 4 to the 1/2 power, and then plus c. And so then what undoes natural log? E. Okay. So what ends up happening is your e and your ln cancel, and you're left with the absolute value of y equals. Okay. In this case, I'm going to have e to actually both things. So really what's going to happen is this is going to cancel here, and I'm going to be left with the square root of x squared plus 4. And then e to the c, remember, refers to a constant, right? Okay, final thing, how do you get rid of the absolute values around the y?
Square it.
What does absolute value imply? Positive, yeah, and the thing is with absolute value, y could be plus or minus. Okay, so the other thing I'm going to do is I'm going to go ahead and put e to the c right there since that's a constant first. And there you go.
Is it plus?
Do you want us to ever like do the square root of that?
You can't do the square root of it.
Is that going to be plus? Isn't it that plus e to the c?
No, it's times, because remember when you have, like if I would have x to the 2 plus 3, that means x to the second, x to the third. Because what you do is you add exponents. So that's the same here. when I added those exponents, it was the same. You can put the base the same. All right, so that's one example that you're going to have with the separation of variables. Let's go ahead and look at another one. Now this one, if you notice, is a little bit more in depth. It says, given the initial condition, find the particular solution of the equation. So what I'm going to do first is I'm going to have to find the general solution to this differential equation, and then I'll be able to plug those values in and find my particular solution. First things first, you have two quantities. Okay, so what I'm going to go ahead and do is I'm going to go ahead and move one of those quantities. So I'm going to go ahead and move this quantity right here to the right. So on the left side, I now have e to the negative x squared. I think that should be e to the negative x squared. Yeah, it is e to the negative x squared times y squared minus 1 dy equals negative xy dx. So far I have dy on one side, dx on the other. So what I need to do is move over my e to the negative x squared. And I also have to move over my y. So I basically did that in 2 steps. This one. Okay? So really what ends up happening is I have y squared minus 1, all divided by y, times dy. And that's going to equal negative x over e to the negative x squared dx. Now real quick, I'm going to simplify a few things before I get going. First of all, I'm going to simplify this deal with the y's. So basically I'm going to divide each individual term by y. And when I do that, I get y minus 1 over y. On the right side, I can actually move this up by doing what? Making the exponent positive. Okay? So now what do you do to solve that? Integrate. Okay. So what is the integration of y? Y squared over, what's the integration of 1 over y? ln equals, now over here, what you're going to do, if you do a u substitution, u is x squared, what's du? 2x. So what I need is I need a positive 2 in here. Actually, I'm going to multiply by a negative 2, so that means a negative 1/2 on the outside. So the integral will be negative 1/2 e to the x squared plus c. So now, what ends up happening is there's really no way to solve this for y. It's going to get extremely messy. So what I'm going to do now is I'm just going to focus on this, plugging this in, and then getting my answer. So it says, given the initial condition y of 0 equals 1. Okay? So what does that mean that you plug in for x? 0. What do you plug in for y? 1. Okay? So 1 squared over 2 is going to give me 1/2. What is natural log of 1? 0. Okay? What do I get here on the right side? What is negative 1/2 e to the 0 power? Negative 1/2 plus c. So in solving that, what do you get c to equal? 1. because you have to add 1/2 to both sides. So c equals 1, so here we go. I've got to fit 1 into that green equation. So the green equation now becomes y squared over 2 minus natural log of y equals negative 1/2 e to the x squared plus 1. Oh, y squared. I said y squared. I don't think I wrote it. There you go. Got better. Okay, so once again, we're pretty much doing the same thing on every problem. Okay, we're first of all separating the variables, integrating, and then finding the solution. Questions? We have one more quick one we're going to look at, and then we'll call it good for today. Find the equation of the curve that passes through the point 1, 3 and has a slope of y over x squared at any point xy. When I hear slope of a curve, what should I automatically think? Derivative. Okay, so the derivative, so basically dy over dx equals y over x squared. So basically what I'm going to do is I'm going to go ahead and find the solution to this and then plug in the 0.13, and that's all we're doing. So let's separate variables. What side should we leave dy on? The left, because it's already in the numerator. So basically, I'm going to move the dx over. What else am I going to do? I'm going to move the y over. So what ends up happening is I've got dy over y equals dx over x squared. And in fact, what I'm going to go ahead and do, instead of writing it as dx over x squared, I'm going to write it as 1 over x squared dx. Okay. That one you can just leave alone because you already know what dy over y is. Okay, we don't really have a rule for dx over x squared. So now let's go ahead and solve. dy over y, ln of y, okay? Now this one, how do you integrate this one? Remember, this one is similar to x to the negative 2 power. So with integrals, remember, you add 1. So if you add 1 to negative 2, you get x to the negative 1 over negative 1, which really simplifies to be what? Negative 1 over x. So I'm going to go ahead and erase that. I know you guys can't really do that, but negative 1 over x. So now I need to solve this. So what am I going to do? How do you undo ln? E. Okay, so on the left side you have y equals. Now really what ends up happening, because I know some of you are probably like, how does this happen? This is what you get when you take e to the both sides. What's wrong? Because that is, if I integrate this, I get x to the negative 1 over negative 1. Okay, so then now, e to the negative 1 over x plus c. Okay, basically means e to the negative 1 over x times e to the c. It's just doing the reverse of adding two exponents together. Okay, so then now what's going to end up happening is I'm going to go ahead and my equation is going to look like this. Y equals c e to the negative 1 over x. Now, for those of you wondering, where did the c come from? What does this mean? It's a constant. Yeah. It's a constant, and so that's what I'm going to plug in for C. It's like when we did the exponential growth and decay. So then now all I'm going to do is I'm going to plug in 1 and 3. I'm going to plug in 3 for y and 1 for x. So basically I get 3 equals CE to the negative first power.
You don't have to do plus or minus.
Because if you look at the graph of this one, it's always going to be positive. Okay. So, what do we get C to equal?
1, 2, 3.
3 divided by
Yep. So basically it's like this, right? E over negative 1 is like this. I mean, isn't that what E to the negative 1 is? So really, what does C equal? 3e to the first equals C. Okay, so now I got to plug that in. And yes, we're going to have to simplify a little bit. Okay, so we're plugging it in here to the yellow. So y equals 3e to the first, okay, times e to the negative 1 over x.
Do you have to put 3 in the first or just put 3?
I would put 3e to the first, and you'll see why in a little bit.
Wait, so what equation did you put in?
To the yellow one. So now you have two bases, right, that are the same. What can you do with those exponents? Add them. So really you get 1 plus negative 1 over x. And that will be your equation. That's why I put the e to the first there. If you wouldn't have had the 1 there, it wouldn't have probably been as easy to see. Okay, questions? All right, that one was a little more in depth. Okay, but this is what you need to do in that section. 1 through 15, the odds. 45 through 48. Okay?